Oh, it's logging me out. Okay, log in. I think I'm live. Hello, everybody. Hello. Okay, now I'm here. I'm live. Hi, welcome to Needs Instagram Live. We have a great energy lesson today using glow sticks. We'll be giving everybody a few minutes to get logged in. Supplies you're going to be needing today are glow sticks. If you have them, don't activate them yet. If you already did, that's okay. Don't stress about it. But I'd like to show you something before they're activated. So if you have 1, 2, 3 glow sticks, you can grab those. We're also going to be using some ice water, some hot water, and tongs, or something to get your glow stick out of the hot water. So you could be gathering up those supplies while we're waiting to get started. So again, glow sticks, ice water, and hot water. I keep getting a message that it's logging me out, but it doesn't look like I'm logged out, so I'm just going to keep talking. And you can let me know if there's a problem on the other end. Okay, so my name's Cori. I'm a middle school science teacher in the west suburbs of Chicago. We've been distance teaching for a while, and I know some of you are at home doing the same thing, going to school online, and so we like to bring you some fun science lessons just to kind of keep things interesting, keep you going at home. So hello, the people that I see joining us right now. Do I know what's going on with the DC trip? I do not, but there is going to be a moderator in here that can answer questions. They might be able to tell you the latest. I'm not sure, maybe somebody, is that going to be you, Becky, that's the moderator? I know there's a little bit of a delay, so I'll wait for that answer. If it's Becky, then I'll pin her comment to the top so you can see it. All right, while we're waiting for people to get joined in, just again, going over materials, glow sticks, some tongs, ice water, and hot water. All right, so I'm going to wait until I find out okay, there we go. All right, so pin comment. All right, so Becky, I just pinned her comment. She's here to answer any questions. So as I get talking and I'm explaining things, if I miss your comment or question, she'll be keeping an extra eye out. All right, so we have our glow sticks. I wanted you to take a look at it before we start doing anything with it. What we're going to be doing today is answering the question, does temperature affect the rate of a chemical reaction in a glow stick? So if the glow stick were to get colder or to get warmer, do you think that would affect how brightly it's glowing? So that's what we're going to be answering today. And if you care to make a prediction here, you can send your comments in. What do you think will happen when we take a glow stick and put it in ice water for a few minutes? What will happen when we put it in some hot water for a few minutes? How will that compare to one that is just at room temperature? Do you think there will be a difference, and why do you think there would be a difference? So feel free to be making your predictions. You can send me comments if you want. In the meantime, I'm going to put this up here so you can take a close look at what is inside that glow stick. So you'll see that there is an air bubble that's sliding back and forth. And if you look closely, you'll see there's something else in there too. You probably already know this, that when you have a glow stick and you want to get it to glow, you're gonna snap it, bend it to get it to start glowing. Just for my moderator, I keep getting a message saying, you've been logged out, please log back in. But it looks like I'm still here, so I guess just let me know if there's a problem with that. Anyway, you'll see that there's a little ampule is what it's called. There's a little capsule inside, floating around some liquid that's on the outside. So if we look at what our glow stick is made of, it's a plastic tube. Inside we have this chemical compound that's an ester and some fluorescent dye. That little tinier tube that you see floating around, that's a capsule that contains something else. There's hydrogen peroxide inside a little tiny glass ampule. And right now those two are being kept separate from each other. But what happens when we snap the glow stick is we're gonna break that little tube in here, then that liquid can mix with the liquid around it, and that will create a chemical reaction. So it's once those two are together, and Becky's telling me that she can see me, so I think we're all good there. All right, so if you have your glow stick at home, you can go ahead and do this with me. Go ahead and break your glow sticks, and I've got 3 of them here. You might even want to give it a little bit of a shake to get it going. And so you'll see that we are now seeing this chemical reaction. Our glow stick is now glowing. Once those 2 chemicals got together, they're releasing that energy as radiant energy, and we're seeing it as light. So I'm going to go ahead and break the other 2 as well. And I don't know if we saw if I had any comments about what would happen if the glow stick was to be in cold water, hot water, room temperature. Any predictions? I'll tell you what my kids at school usually say. A lot of times they think that it's going to glow brighter when we put it in ice water. And the reasoning for that is they know from their own experiences, or what they've heard, is that if they put a glow stick in the freezer, it will last longer. So a lot of times they think that that will have something to do with how it reacts. So you can be thinking about that. I'm going to be go ahead and put it in. If you have this at home and you're doing this along with me, you can start. There's our ice water. Technically, I should have done this all at the same time. I got my hot water. You want to be careful your hot water is not too hot, about 85 degrees Celsius. You don't want it hotter than that, or your glow stick might leak. What I told my kids at home, because they probably don't have a thermometer on hand, try to get it as hot as it would be if you were going to be drinking hot chocolate. So you want it to be a hot drink, but you don't want it to be burning your mouth. So it gives you kind of an idea of how hot you want it to be. So we're just going to let those sit there for about 2 to 3 minutes. While those are sitting, we'll talk a little bit more about chemical reactions. So I've got a couple of things to show you. We could do a physical change or a chemical change. So we'll talk about what the difference is between those. If I have a piece of paper, and we do have somebody that wants to be in our live video, let's see, I'll go ahead and do that. We're waiting. All right, while we're waiting. So this piece of paper, I can take my scissors and cut it in half. And if I do that, now I have 2 pieces of paper. Have they changed? Has the paper changed? It's changed in size, but it's still paper. So this is just a physical change. Same thing could happen with rocks. A rock that's being weathered and broken into smaller pieces, still the same rock, it's just changed in size. So that is just a physical change. But here I have a piece of bread. And if I put a piece of bread in the toaster, it comes out like this. Now you'll see we have a change. This is a chemical change where we had something change here. We've got a color change. We see that it's changed from this bread to this piece of toast. So a chemical change. And again, the piece of paper, just a physical change, just getting smaller. I don't know if that worked with somebody that wanted to chime in at home. Okay. So we've let a couple minutes go by. I'm going to let it go just a little bit longer for our glow sticks that are going through that temperature change right now. Just a little bit more about what is happening there. And if I didn't mention this before, what was inside that, we had the fluorescent dye and the ester that's in the outside, and the little capsule that was in the middle had hydrogen peroxide in it. That is what they will put on your cuts sometimes. So that may be your experience with hydrogen peroxide in the past. And when those two were put together, they don't need as much energy to hold their molecules together. So they're releasing that extra energy as light. All right, it's been a few minutes. So I'm going to take this camera to a different location. This might seem kind of strange, but we're going to go into my bathroom. That is because that's a spot in my house that's really dark. I'm in the kitchen now. It's really hard to make it darker in this room. So we'll go on in there, then you'll really get a chance to see how these are glowing and what the differences are between them. So Okay, so there's our room temperature one, our ice water and our hot water. I'm gonna make sure that you can see all three. And I'll close the door. This room has no windows, so it makes it a lot easier to see. So again, here's our glow stick that it's at room temperature. The one that has been in the ice water for a few minutes, I'll put that one side by side. You can see the ice water one is not glowing as brightly as the one that was at room temperature. Now if we take the one that's in the hot water, and I should have grabbed my tongs, the hot water next to our room temperature one is much brighter. If you had just one glow stick, it's maybe a little bit hard to do a comparison, but side by side you can see the difference. So again, we've got our cold water, room temperature, and the one that was in the hot water. All right, so I'm going to take the camera back out to the front so we can talk about what is happening. All right, and when we had our glow stick in the cold water, we'll start with the one that was in the hot water. The one that's in the hot water is absorbing thermal energy from the hot water, and it's making the reaction go faster, and it's glowing much more brighter, as you saw. The one that was in the room temperature stayed the same. The one that was in okay, sorry. It does make me a little bit nervous to be going live. Okay, so the chemical reaction's happening faster in the hot water. It's making it react more quickly, and it's giving off more of that light. It's glowing more brightly. The cold water one was slowing it down. If you had just a regular glow stick at room temperature, it's going to glow for about 2 hours. When we put it in the hot water, it's glowing more brightly at the time, but it's going to go faster, so it's going to be done glowing in about 30 minutes. In ice water, though, it could glow for up to 6 hours, even though it's not glowing as brightly. So that added energy is making those chemicals react faster, produce more light in a shorter amount of time, and it was slowing it down with the ice water. Overall, it's producing the same amount of light. It's just that it is going to have that chemical reaction rate go faster when it was in the hot water. So I know that went maybe a little bit faster than I had originally thought. Does anybody have any questions? That was a great question about the DC trip. I saw that Becky had answered that. Does anybody else out there have any questions? So I'm going to invite you to come back. If this was your first time to come to a Need Instagram Live session, welcome to the first one. They do this every Tuesday and Thursday, so there will be another one this Thursday. So please come back and join us in the future for the Tuesday and Thursday, 2 o'clock Eastern time. And I will see you next time. Bye.